Okay, so now you've had a chance to practice differentiating exponential and logarithmic functions. We're going to look at the product rule, right? The product rule is as it suggests, okay? Product means multiply together. So if we're looking for the product rule, it's the rule that allows us to multiply together or to differentiate, sorry, two functions that are being multiplied together, right? You won't have really noticed this, but throughout higher, you never had to tackle a question like this because it's obviously that little bit more difficult. So you looked at chain rule to an extent, but you never looked at something like this, okay? The main, I think, battle comes with this, and we've still got quotient rule to come, is knowing the difference between chain rule and product rule. So make sure you practice this and you kind of get used to what we mean by the product rule and when we use it. I'll explain it a little bit more in a second once I give you some examples, okay? But it's basically when we have a situation like this. So just using the notation for two functions. So it doesn't matter what those two functions are, but the point is they're multiplied together, okay? So our overall function is a product of two functions. So f of x times by g of x. Right, there's different ways of writing how we would differentiate this, but I generally kind of write it like this. This is obviously a shortened version of what's above, and as I say, there's different ways of writing it. You saw when I did the chain rule that you can use and whatnot. This is just generally the version that I'll use, okay? So when you have two functions multiplied together, it's f dash g plus g dash f, which can be difficult to say, and if I have to say it throughout this video, then yeah, I'll probably struggle. But what it basically means in kind of shortened form is it's the derivative of one of the functions multiplied by the original function undifferentiated plus the derivative of the function that you didn't yet differentiate multiplied by the original function of the one that you did. Okay, so f dash g plus g dash f is what we're going for here. And this is in a situation when we have two functions multiplied together in the first instance. So I'll give you a couple of examples so you can get used to this. Okay, so this is the kind of thing that we're looking for. So it won't ever say use the product rule, just in the same way they didn't say use the chain rule. And in an exam, you're going to get lots of differentiation. You have to identify which rule is required. So this one is a product rule because it's two separate functions in terms of x multiplied together. So on one hand, x is being squared. On the other hand, x is being we're finding the sign of that x, and those two functions are multiplied together. So it's very easy to change this interchain rule. So for example, if I said sine x squared or sine squared x, that would be the chain rule. You can kind of spot if there's generally kind of two x's. Okay, so if there's more than the one x throughout your function, you're generally probably going to have to use the product rule. Okay, most of the chain rule ones that we've done so far is just one x, but there's just different things happening to it. So the x has been squared here, and a whole different x we're finding the sign of. So it's two separate functions multiplied together. That's when we use the product rule. But as I say, it can be very similar to the chain rule in terms of identifying at the start, so get used to that. So I write this in a very specific way. I've kind of split the two functions off into an f of x and a g of x. So I'm just going to let f of x equal x squared here and g of x equal to sine x. Doesn't matter which way around you do it. Okay. At the end of the day, we're just multiplying and adding things together. And generally, if we're multiplying and adding kind of two things together, it doesn't really matter what order we do it in. So I could have gone f of x equals sine x, g of x equals x squared. It doesn't necessarily matter because x squared times by sine x would be the same as sine x times by x squared. Right, so differentiate each one individually. F dash x is 2x, g dash x would be cos x. And then it's just a case of substituting it into your formula. So you might want to write it down just to get used to it. So f dash g plus g dash f. Okay, and what you'll notice here, you're kind of multiplying these two together and then adding these two multiplied together. And if you write it like this, it kind of becomes a habit almost to kind of do the next stage. So it's 2x times by sine x plus cos x times by x squared. Okay, from here on out, it's just a case of simplifying it as best as you can. And what you'll find is that if you're looking at the answers, especially, they might simplify it in a slightly different way. Okay, but 2x times by sine x is just 2x sine x. X squared times by cos x, you generally want to put the x squared first so as not to get confused with what you are finding the cosine of. What you might find in exam in answers, there was something like this. They seem to have a habit of just taking out common factors and making that simpler. It isn't necessarily the case that it is simpler. Obviously, here we're not writing the fact that it's squared. So it's not making that much of a difference in terms of simplifying, but just look at in terms of the answers. Okay, and that's it done. That is the product rule, two functions multiplied together, okay? So similar kind of idea, okay? It doesn't, it can involve trigonometry, it can involve exponential, logarithmic functions. You've just got to identify that it is two separate functions in terms of x multiplied together. So an x plus 3 to the power 4 is being multiplied by an x minus 3 to the power 5 here. So is the product rule. In each case, though, we would have to consider the chain rule. If I put something in terms of, if I put a 2x there, so I put a 2 in front of either x, or if I made the x squared, then suddenly it becomes a chain rule within the product rule. Okay, I'm not going to go that harsh just yet, but that is what you have to look out for. Okay. Either way, I suggest you write it like this. F of x is x plus 3 to the power 4. That's our first function, in which case g of x is the other one. And then just differentiate each one individually. 4 times by x plus 3 cubed. So this is kind of the higher chain rule that you did. You basically sticking the 4 in front and dropping it by 1. Sticking the 5 in front, dropping it by 1. But in theory, what you're doing in both of these cases is you are multiplying by the derivative of what's in the brackets. Okay, but the derivative in each case is just 1. Okay, so if there was a 2x there or an x squared there, then this becomes that little bit more complicated, and you must think about the chain rule a bit more carefully. Okay. Right, so then to actually complete this, okay, so to get the derivative of the whole thing, it's this derivative times by this plus this derivative times by this. Okay, so just write down like that, which looks horrendous, and to be fair, there's not a massive amount we can do with that. You can write it like that. And again, if you're kind of thinking in terms of common factors, if you're thinking in terms of common factors, then you've technically got x plus 3 to the power of 3 times by x minus 3 to the power of 4 as a common factor. And they get a little bit funky in terms of the answers there. So if I try and do this in my head, the answer might be something like x plus 3 to the power of 3 times by x minus 3 to the power of 4. And then open up the brackets, 4 bracket x minus 3 plus 5 bracket x plus 3, close bracket. And then to be honest, you can simplify that a little bit. But I am happy for you to leave it just like this, okay? Right.